Hi everyone, I am Neelav Bhatiya and I attempted my JEE in the year of 2020 wherein I secured a rank of 1755. In the previous sessions we had solved two exercises from the chapter sequence series, and we had also started with some of the questions of the miscellaneous exercise at the end of the chapter. Today in this session we'll be using all the concepts and fundas that we learned in the previous sessions, and we are going to apply them in the last exercise. And today we'll be able to finish this chapter off. And yeah, without wasting any more time, let's jump to the exercise. So in the previous session, we had seen the first four questions of this exercise. Starting today, we are going to see the fifth question. So in question number 5, we have been told a GP consists of an even number of terms. If the sum of the terms is 5 times the sum of terms occupying odd places, then we need to find its common ratio, right? So first of all, the first information that has been given to us is that there's a GP and it consists of an even number of terms. So if it does consist an even number of terms, can I say that this particular GP has 2n terms? I can say that, right? Because 2n is going to be any even number and I can represent the total number of terms in this GP as 2n because they are even, correct? So the terms in the even places would then be second, fourth, sixth, and so on and so forth up until the 2nth term, right? Similarly, the term in the odd places would be first, third, fifth, up until 2n minus 1. These are going to be the terms of this GP in respective even and odd places, and both of them are going to constitute of n terms. Why is this important? Because as we have been told that this GP contains even number of terms, so the number of terms at odd places is going to be equal to the number of terms at even places, and those are going to be n terms, right? So knowing this information, let us try to derive an equation out of the facts that have been given to us. We have been told that the sum of all the terms is 5 times the sum of terms occupying odd places. So the sum of terms occupying odd places, let's denote that by S, or let's just write the sum of terms occupying odd places, would be written as A1 plus A3 plus A5 up until A2n minus 1, and you multiply this entire summation by 5, you get A1 plus A2 plus A3 up until A2n. Right? This, what I've done right here is I've expressed, so the solution starts from here. I've expressed the information that has been given to us in the form of equation. This right here represents the sum of all the odd terms. Multiply that by 5 and you get the sum of all terms in the GP, right? Now, can I segregate the RHS as, let me just write this down and then I'm going to explain it to you, right? So LHS, I'm not doing anything else with LHS. I'm just writing is as it is, right? This is my LHS is equal to, can I write the RHS as A1 plus A3 plus A5 up until A2n minus 1 plus A2 plus A4 plus A6 plus A8 up until A2n. Correct? I've done nothing but I've segregated the odd terms in the even terms. If you see right here, this also forms the summation of odd terms. So can I consider this entire summation as being one part of the sum expressed in the LHS? Can I do that? Because this is nothing but the term that is written in the bracket itself, right? Let us denote this entire summation of odd terms as O. Let's say O is equals to A1 plus A3 up until A2n minus 1. And let's say the summation of even terms as A2 plus A4 up until A2n. Then when I write my equation, it's going to be something along 5 into O equal to O plus E, right? Because the O plus E represents the summation of all the terms in the GP. Now taking O onto the LHS side from RHS, you get 4O equals to E. So this would imply that 4 times the sum of odd terms is going to be the sum of even terms, right? On the LHS, you would have something along. Now I'm going to represent the GP in the form of first term being A and the common ratio being R, right? The first term of odd terms at the odd places is going to be A because the first term is A. Then it's not going to be AR, rather it's going to be AR square. Now why is that? Because the second term in the series here would be the third term and not the second term itself. Then you would have AR square and so on and so forth up until A R is to the power 2n minus 2, right? And on the RHS, you would have AR plus AR cube plus AR power 5 up until plus AR is to power 2n minus 1. So the number of terms in LHS is n, number of terms in RH is also n. Here the common ratio is R square. Here the common ratio is also R square. The first term is A here. The first term is AR here. Now I'm going to use the formula of summation in GP and I'm going to write down what the equation is now going to be, right? So in the LHS you would have 4 into the first term is A. Common ratio would be R square. So it would be something along these lines, minus 1 upon in the denominator you would also have R square minus 1, right? In the on the RHS you would have AR because the first term here is AR, not A, right? Because you're talking about the second term, not the first term in general. Then you would have R raised to the power 2R into n. I'm sorry. It's also going to be 2n because n represents the number of terms in the GP, minus 1 upon R square minus 1. R square minus 1 gets cancelled. R raised to the power 2n minus 1 gets cancelled. What you now have is 4A equals AR, cancelling A out on both sides. The common ratio is 4, right? And we had been asked to do that. We had been asked to find the common ratio of this particular GP. We've done that. So yeah, that is the solution. Moving on. In the next question, then we'll start from here itself. So now moving on to question number 6, right? In question number 6, we have been told that if A plus Bx upon A minus Bx equal to B plus Cx upon B minus Cx equal to C plus Dx upon C minus Dx, then we need to show that A, B, C and D are in GP, right? Now, first, let's take the first two terms of this question. We have been given that A plus Bx, A minus Bx equals to B plus Cx upon B minus Cx. Cross multiplying these both terms, you would have A plus Bx into B minus Cx equals to A minus Bx into B plus Cx, right? A and B gets multiplied, so you have AB plus, you then have plus B square x, then you would have going to be minus ACX, is going to be minus BCX, correct? On the RHS, you would have AB minus B square x minus BCX plus AC. I have done so. Is this the correct part? Minus BCX minus BCX. Then you would have plus ACX. And yeah. So this is going to be our equation when you take the first two terms. AB and AB gets cancelled. Minus BCX and minus BCX gets cancelled. You would now have, now I'm taking this term onto the LHS and I'm taking this term onto the RHS. So you would have 2B square x equals to 2ACX, right? 2 and 2 gets cancelled, x and x gets cancelled. B square equals to AC. Expressing this as something else, you would have B upon A equal to C upon B, proving that indeed A, B and C are in a GP. Correct. So we now have A, B and C in GP. Now it would be sufficient to prove that B, C, D are also in a GP, and that would imply A, B, C, D are in a GP. Considering the second term of this particular question, you have C plus dx. I'm sorry, you would have B plus Cx equals to B minus Cx, and you would have C plus dx upon C minus dx. Again, cross multiplying these both terms, you would have B plus Cx into C minus dx as being equal to C plus dx into B minus Cx. Right? You would have BC minus BDX minus CDX plus C square x. Correct? On the RHS, you would have BC minus C square x plus BDX minus CDX. Minus CDX gets cancelled. BC gets cancelled. You would then have 2 times C square x equals to 2 times BDX. X and x gets cancelled. 2 and 2 gets cancelled. Re-expressing this as C upon B equal to D upon C. Doing this again, you would then say that B, C, and D are in GP. But we also know that A, B, and C are in GP. So this both statements would then imply A, B, C, and D are in GP. Correct. So I have proved that A, B, C, and D are in GP, which was asked of us in this question. Moving on, question number 7. Right. In question number 7, we have been said that let S be the sum, P be the product, and R the sum of reciprocals of n terms in GP. We need to prove that P square R raised to power n equals to Sn. Right. Now, we have been said that P, let's assume the, first of all, let's assume the GP to be AR up until AR raised to power n minus 1, and these are the n terms of G. Then P, or the product of the terms, would be A into AR into AR square up until into A R raised to power n minus 1. Right? So, and A has been multiplied n times, so you have A raised to power n into R raised to power summation of 1 plus 2 plus 3 up until n minus 1 would be R raised to power n minus 1 into n upon 2. Correct? And this is going to be the product of the terms. Right? Because the powers get added up. Now, the summation of terms of n terms up until in the GP is very straightforward. We already know the formula. It's going to be A R raised to power n minus 1 upon R minus 1. So we also have the summation of all the terms in GP. Now we have been said that R is sum of the reciprocals of terms in the GP, right? So we have assumed the GP to be A, AR, AR square, and so on and so forth, right? Therefore, 1 upon any term, n term, would be 1 upon A, next term would be 1 upon AR, next term would be 1 upon AR square, and so on and so forth. In this particular GP, again, the number of terms is n. The first term is A by 1 upon A, and the common ratio is 1 upon R. Therefore, R, or the summation of reciprocals of this GP, would be 1 upon A. Into bracket, you would have 1 upon R raised to power n minus 1. Here you would have R minus 1. Correct? Simplifying this, you would now have 1 upon R raised to power n. I have done nothing. I have just taken the common ratios, and in the denominator you would have 1 minus R upon right? Therefore, in the numerator, taking minus out from both the numerator and denominator, you would have r raised to power n minus 1 upon r raised to power n into r minus 1 into r on 2a. R and r gets cancelled 1 minus 1 times. So the final term, final summation could be expressed as r raised to power n minus 1 upon a r raised to power n minus 1 upon r minus into r minus 1. Right, so this is r. We have been said to prove that p square r raised to power n is going to be s raised to power n. So let's see what p square is going to be, right? P square is going to be a raised to power n r raised to power n into n minus 1 by 2 whole squared, right? Because we are raising it to, and you would now have r raised to power n minus 1 upon raised to power n. You would have a raised to power n, r raised to power n minus 1 into n, and r minus 1 raised to power n. How did we get this? We got this by doing nothing but multiplying by raising the summation r we got in previous equation to the power n. Right. Now let us write all of this in one line and see what we get. So in a's power you have a raised to power 2n, right? Minus a raised to power n, because a raised to power n right here is in the denominator. So you would have a raised to power 2n minus n. Here you would have r raised to power n minus 1 whole raised to power n. Another, so this is all for the numerator. In the, and then you would also have r raised to power n into n minus 1, right? In the denominator you would have r raised to power n minus 1 into n, and you would have r minus 1 raised to power n. This right here and this right here gets cancelled, and finally you have a raised to power n r n minus 1 raised to power n upon r minus 1 whole raised to power n. As you can see, all these terms are raised to power n. So n can be taken out common. Finally, you would have a into r raised to power n minus 1 upon r minus 1 whole raised to power n. And this is nothing but the summation of the terms in GP and could be written as S, which is S raised to power n, which is ultimately equal to RHS, hence proved. Correct. Moving on. We are talking about question number 8 now. We have, if A, B, C, D, we have to prove that if A, B, C, D are in a GP, A raised to power n plus B raised to power n, comma, B raised to power n plus C raised to power n, comma, C raised to power n plus B raised to power n are in a GP as well. So we have been given 4 terms in this GP, right? A, B, C, and D, right? Let's assume these 4 terms to be A, AR, AR square, and AR cube. So the first term in the GP that we need to prove is A raised to power n plus B raised to power n. And what would that be? That would be A raised to power n plus A raised to power n R raised to power n. Taking A raised to power n common, you would have R raised to power n plus 1, right? And this would then be your first term in this GP, right? So A raised to power n is going to be this. Secondly, you would have b raised to power n plus c raised to power n. What would this be? This would be a raised to power n, a raised to power n, r raised to power n plus a raised to power n, r raised to power 2n. A raised to power, taking out a raised to power n common and r raised to power n common, you would have r raised to power n plus 1. Right. The third and the final term in this supposed GP would be c raised to power n plus d raised to power n. Again, this would be a raised to power n, r raised to power 2n plus a raised to power n, r raised to power 3n, and subsequently it would be a raised to power n, r raised to power 2n common. In the brackets you would have r raised to power n plus 1. Right. so this is going to be your third, going to be a second, and this right here is going to be your first term, right? To prove that these three terms are in a GP, it would be sufficient to prove that second term divided by first term would equal third term divided by second term, right? The second term is going to be a raised to power n, r raised to power n, a raised to power r raised to power n plus 1 in the brackets. First term is going to be a raised to power n, r raised to power n plus 1 in the brackets. And similarly, the third term is going to be, so this is going to be your LHS, right? So this would equate cancelling, sorry, a raised to power n is power n gets cancelled. This gets cancelled. So the common ratio you obtain is r raised to power n. This is your LHS. Similarly, RHS would be third term upon second term, and that would be a raised to power n, r raised to power 3n upon into r raised to power n plus 1 divided by a raised to power n. I'm sorry, this is going to be 2n, and this will be a raised to into r raised to power n, r raised to power n plus 1, right? This and this gets cancelled, a raised to power gets cancelled. You would, this gets cancelled one times, and you would have r raised to power n, which is then going to be equal to your LHS as well. And because the common ratio is going to be the same, we can say that a raised to power n plus b raised to power n, b raised to power n plus c raised to power n, and c raised to power n plus d raised to power n are in GP. Correct? Moving on. In question number 9, we have, if a and b are the roots of the equation x square minus 3x plus p, and c d are the roots of the equation x square minus 12x plus q, where a, b, c, d form a GP, we need to prove that q plus p raised to ratio q minus p is going to be 17:5, right? So how are we going to prove this? First of all, we have been said that A, B, C, and D are in a GP, right? So can we assume A, B, C, D to be X, XR, XR square, and XR cube? Can I assume that? How can I assume that? Because we have been already told that these three terms are in a GP. Therefore, A and A plus B, so A plus A and B are the roots of equation x square minus 3x plus p, and C and D are roots of the equation x square minus 12x plus q, right? So a plus b would equal to 3, and a into b would equal to p, correct? How did I do this? I did this because we know that the sum of roots and product of roots is going to be b by minus b by a and c by a respectively, right? But I've also written a and b to be of the form x and xr. So I'm going to just replace that. So x plus xr is going to be 3, and x square r is going to be p, right? Similarly, c plus d c plus d is going to be 12, and cd is going to be q. Writing them in the form described earlier, you would have xr square plus xr cube equals to 12, and x square r raised to power 5 is going to be q, right? The ratio we are required to find out is q plus p upon q minus p, right? So let's try and solve this. Q would equate r raised to power 5, or let's not try and find out the ratio first. Let's try and solve for x and r from the equation that have been given to us. So here you have x plus xr equals to 3. Taking x out common, you have r plus x into r plus 1 equals to 3. Similarly, here you have x r square plus x r cube equals to 12. taking x r square common, you have x1 equal to 12. Correct. Dividing this equation by this equation, you then have r square r plus 1 into x upon x r plus 1 as equals to 4, but because 12 divided by 4, 10 divided by 3 is equal to 4. R plus 1 gets cancelled, x and x is cancelled. R square is equal to 4, right? R is equal to plus minus 2. Let's take these two conditions and try and prove that irrespective of what the value of R is going to be, the ratio between P plus Q plus P and Q minus P is always going to be same. So for R equals to 2, you have x into 3 equals to 3. Therefore, x equals to 3. X equals to 1. Right. For r equals to minus 2, you would have x into minus 2 plus 1 equals to 3, and therefore you would have x equals to minus 3. So r equals to minus 2 and x equals to minus 3 would give you, would be, and then this would be r equals to 2 and x equals to 1. P is going to be x r square and Q is, P is going to be x square r and Q is going to be x square r raised to power 5. So for this case, for case number 1, P is going to be x square is going to be 1 and r is going to be r, so P is going to be 2, and Q right here would be x square is going to be just 1 and r raised to power 5 is going to be 32. Right. In this case, P is going to be x square. So x square is nothing but 3 square, which is 9. 9 into 2, 9 into minus 2 is going to be minus 18, and Q is going to be minus 288, because I've done nothing here, but I've plugged in the value of x equals to minus 3 and r equals to minus 2 in this case. In case number 1, P plus Q or is going to be 32 plus 2 upon, you would have 32 minus 2, right? This is going to be 34 upon 15, and that is nothing but, that is going to be 34 upon 30, and that is nothing but 13 upon 50, right? So P plus Q upon Q minus P is going to be 17 by 35. In this case, P plus Q would then be minus 288 minus 18 upon minus 288 plus 18. So this would be 306 upon minus 306 upon minus 270. When you take this out common, you would have 17 by 15. So irrespective of what the values of R and X are going to be from our question, the ratio of Q plus P and Q minus P is always going to be 17 by 15. Correct. Hence proved. Moving on to question number 10. Right. In question number 10, we have been said that the ratio of AM and GM of two numbers is going to be M ratio N. We need to show that A ratio B is going to be M plus under root M square minus N ratio M minus under root M square minus N. Right. So the numbers have been given to us as A and B. The ratio of AM and GM of these numbers is going to be M ratio N. Therefore, A plus B upon 2 upon root AB is going to be M ratio N. Right. Therefore, you would have A plus B upon 2 ratio AB is going to be M ratio N. Right. Multiplying this, you would have upon N. Right. Taking square on both the sides, you would have A plus B whole square equals to 4AB M upon N. Right. We also know that A minus B whole square is equal to A plus B whole square minus 4ab. Correct? This is m square n square. Sorry, when you square it up, it gets cancelled. So a minus b whole square would be 4ab m square n square. I am replacing the value of a plus b whole square here and minus 4ab here. Right? Therefore, a minus b the whole square would equal 4ab. You take that out common. In the brackets, you would have m square minus n square plus 1. Taking the roots out common, taking root on both sides, you would have a minus b as being equal to 2 root ab m square minus n square minus 1 whole. Correct? So when you add up a and b, when you add up this equation and this equation, you get 2a equals 2 root ab m square m by n minus 2 root ab, I'm taking n out common, into bracket m square minus n square. Right? Taking these two out common, you would then have, or we have added up, so this is going to be plus. So this would then be, to take 2 root ab m upon n out common in the brackets, you would have, or m, you don't take m out common, you take this out common, and in the brackets, then you would have something along these lines, m plus under root m square minus n square. Correct? This is going to be the value of your a. A is going to be this. Right? Similarly, when you plug in this value in the equation a plus b, so let me just do that. We have been told that a plus b is equal to 2 root ab m upon n. Sorry, here the 2 gets cancelled because yeah, here the 2 gets cancelled because it was available earlier. So here here a would be, so plugging in this value into this equation, b, sorry, I'll write b here, b plus a, value of a is nothing but root ab m upon n plus root ab by n, into brackets you would have m square minus n square, and this is equal to 2 root ab m upon n. Right? Taking this entire term of a out onto the RHS, you would have b as being equals to ab on n minus root ab upon n in the brackets m square minus n square. Right? Taking root ab upon n common, you would have b equals to root ab upon n in the brackets, you would have m minus under root m square minus n square. You now have the value of a as it is expressed right here, and below you have the value of b. So a upon b is going to be nothing but root ab upon n upon root ab upon n. In the brackets, you would have m plus under root m square minus n square. In the brackets here, you would have m minus under root m square plus n square. Correct? This and this gets cancelled. A upon b is going to be m plus under root m square minus n square upon m minus under root m square upon minus n square. Right? So hence, correct. So moving on, we are on to question number 11. Right? In question number 11, we have been asked to find the sum of the following series up until n terms. Right? How are we going to do this? I'm going to approach this question. We have done a similar kind of question in the previous exercises as well. We are going to solve it using the same approach we did in the previously, and yeah, let's see how we're going to do this, right? So for the first part, we need to find 5 plus 5 plus 55 plus 555 and so on and so forth. For the n term, it would be 555 n times. Correct. Taking out 5 by 9 common from this, you then have, if you take out 5 and you multiply this by 9, so you take, this will be outside, inside it would be 9 plus 99 plus 999 up until 9 n times. Correct. You can write 9 as n minus 1, 99 as 100 minus 1, and this as 0 being n times minus 1. Therefore, this would be 5 upon n. This would be 10 raised to power 1 plus 10 raised to power 2 up until 10 raised to power n minus 1 minus 1 up until n times. Correct. So, in essence, it would be 5 upon 9. This would be an AP with the first term as 10, number of terms as n minus number of terms as n, common ratio as 9. So R minus 1 would be 9, right? In the brackets, you have minus 9. Multiplying this into the brackets, you would have 50 upon 81, 10 raised to power 9 minus 10 raised to power n minus 1 minus 5n by 9. This is going to be your sum of plus 0, so 0.6 plus 0.666 up until 0.666, and this is going to be n times. As we did in the first question, we are going to take 6 and 9, 6 common from the numerator and 9 common from the denominator, right? So we would have 6 upon 9 into brackets, it would be 0.1 plus, it would be 0.9 plus 0.99 and so on and so forth up until 0.999. So this could again be expressed as, if you have 6 upon 9 outside, this could be written as 1 minus 0.1. 0.99 could be written as 1 minus 0.01, and this would finally be written as plus 1 minus 0.0000 n times as 1, right? So again, you would have 6 upon 9. You would add 1 up n times, so you would have n here, minus the first term is going to be 0.1. Common ratio is also going to be 0.1. So you would have 1 is 1 minus 0.1 raised to power n. And in the denominator, you would have 0. Multiplying 6 by 9 to the brackets, you would have 6n minus 1 minus 0.6 upon 8.1, 1 minus 0.1 raised to power n, and this is going to be a sum for n terms, right? Moving on to question number 12, we have been asked to find the 28th term of the series 2 into 4 plus 4 into 6 plus 6 into 8 up until n terms, right? So the first term of the series, can it be written as 2n, right? So the first term of the series is 2 into 4, correct? Can this be written as 2n into 2n plus 2, right? Can I write the nth term of the series as this? Try to visualize this. So the first term is going to be 2 into 4. Similarly, the second term is going to be 4 into 6 and so on and so forth. So this comes out to be a right formula for the nth term. So the formula for the nth term is going to be 2n into 2n plus 2. We have been asked to find the 28th term of this series. 28th term is now going to be 2 into n. Let's suppose the value of n is 20 into 2 into 20 plus 2. So here you would have 40 into 42, and that is finally going to come out to be 1680. Right. So that was the answer for question number 12. Moving on to question number 13, we have been asked, a farmer buys a used tractor for 12,000 rupees. He pays 6,000 cash and agrees to pay the balance amount in annual installments of 500 plus 12% interest on the unpaid amount. How much will the tractor cost him? Right. The used tractor was bought off for costed $12,000 in total. Right. He paid 6,000 upfront, and every year he paid 500 plus 12% interest on the remaining amount. Right. So the amount he paid in interest is going to be 12% of. So in the first year he paid 12% interest on 6,000. In the second year he paid 12% on 5,500. On the third year he paid 12% on 5,000, and so on and so forth. Right. So the interest he paid would be 12% of 6,000 plus 5,500 up until 500. Right. This is going to be your interest calculator. The amount he paid upfront is going to be another 6,000, plus he also paid 500 for 12 times up until his installment of 6,000 was over. Right. So this is going to be your final answer. Now, number of terms in this particular AP are also going to be 6,000, right? A number of terms in this particular AP of 6,000 plus 4,500 plus 500 and so on and so forth are also going to be 12, because he paid 12 installments of 500 each to get to 6,000. So the interest he paid would be 12%, or let's just write 12 upon 100 into 12 by 2, number of terms divided by 2, the formula of summation of terms in AP. 2 into A, 2 into first term. Let's assume the AP to be reversed, not starting from 6,000 but starting from 500. So it would be 1,000 plus number of terms is 12. So you would have n minus 1 as 11 into 500 right here, plus 6,000, the amount he paid upfront, plus 6,000 other thing that he paid as installments, right? So this would be 12 upon 100 into this, and calculate this entire thing. It's going to amount to 39,000, and you can cancel these two zeros out, plus 12,000, the other things that he paid, right? So this interest is going to be 4,680, and the remaining amount that he paid is 12,000, right? So the entire cost for the tractor that he paid is going to be 16,680, right? This is a kind of a tricky question. Just make sure you keep in mind how much interest is he paying each year and how much upfront amount has he paid, right? And that are you going to be able to solve this question, right? Moving on. In question number 14 is going to be a similar question. Let's try to do it better this time. We have been asked that Samshad Ali buys a scooter for 22,000. He pays 4,000 cash and agrees to pay the balance amount in installments of 1,000 plus 10% interest on the unpaid amount. How much will the scooter cost him? Right. So he has paid, the scooter was 22,000. The upfront amount that he paid is 4,000. So that gets added up. Plus he pays 10% interest on amount each year. So for the first year he pays 10,000 on 18,000, plus next year is going to pay on 17,000 up until 1,000, right? And the amount of installments that is going to pay are 1,000 plus 1000 up until this amounts to 18,000. So the other amount in installments of 1000 that gets deducted from the principal is going to be 1000 into 18. So the total amount that he paid is 4000 plus installments every year, and that is going to be 18,000 again. This 18 into 1000 plus 10% on this amount, and that is going to be 0.1. Just I've just written, okay, for the sake of it, let me write 10 upon 100 is going to be 10% of this entire AP would have 18 terms. A would be 1000 and D would also be 1000, right? So it would be 18 upon 2 into 2A. 2A would be 2000 plus 17,000, right? And when you calculate this entire thing, is going to be 22,000 plus n upon 100, and this amount is going to be 17100 000. I'm sorry, cancel out 0 and 0 right here. So the total amount that is going to pay is 22,000 plus 17100, and we add this up, it's going to be 39,100, right? That is the amount he is paying, correct? Moving on, in question number 15, we have person writes a letter to 4 of his friends. He asks each of them to copy the letter and mail to 4 different persons with the instructions that they move the chain similarly. Assuming that the chain is not broken and it costs 50 paise to mail each letter, find the amount spent on brokerage when the 8th set of letter is mailed. So a person, so let's say the person is P, writes a letter to 4 of his friends, right? So the first set of letters is 4. F, 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 F. Similarly, each of these friends mails to 4 letters, mails 4 letters as well. This is going to come out to 16. Similarly, the next set of friends also mail out to 4 each letter, and this is going to come out to 16 into 4, and that is nothing but 64 letters. So the number of letters mailed at each turn is going to be 4 power n, right? So for the 8th set of letters mailed, the number of letters are going to be 4 raised to power 8, and the total amount that it costs to mail this letter is going to be, or the GP has A as 4 and the common ratio has also been 4. We need to find the total amount spent when 8th cell of letter is mailed, right? So the number of terms is also 8. Therefore, the summation of this GP SN is going to be 4. First term is 4 into 4 is to power n minus 1 upon 3, and the amount spent would be 0.5 into S, because we are spending 0.5 paisa, which converted to rupees is 0.5 rupees into S, and that will be 2 upon 3, 4 is to power n minus 1, right? This entire, when you calculate this out, will be 2 upon 3, 4 is to power 8 minus 1, and calculate this amount out, it's going to come out to be 43,690 rupees. Right, so this is your final answer. Moving on to question number 16. Question number 16, we have been told that a man deposited 10,000 in a bank at the rate of 15% simple interest calculated. Find the amount in 15 years since he deposited the amount, and also calculate the total amount after 20 years, right? So the amount he deposited is going to be 10,000, right? He deposited this amount at 5% simple interest annually. The amount in 15th year is going to be principal plus interest that generated after 15 years, right? So This is going to be, the principal is going to be 10,000 and the interest generated every year is going to be 500. How did I get that? Because 5% of 10,000, calculate this out, is going to be 500, right? So, and the interest calculated every year is 500 plus 500 plus 500 up until, and this will add up until 14 times. Now, why 14 times and not 15 times? Because we have been asked to calculate the amount at the 15th year, right? So it would be 10,000 plus, here you would have a GP, here you would have 500 into 14, and this would be 10,000 plus 7,000, and this would be 17,000, right? Moving on, we need to also find total amount after 20 years. So after 20 years, same, it's going to be 10,000 principal amount plus 500 plus 500 plus 500 up until 20 times. Why 20 times this time and not 19 times? Because we have been asked to calculate the amount after 20 years, right? So it's going to be 1000 plus 500 into 20, and this is going to be 10,000 again. Here you would have 10,000 plus 10,000. So the amount after 20 years is going to be 20,000. Moving on, we are going to be now discussing question number 17. Right. A manufacturer reckons that the value of a machine which cost him 15,625 will depreciate each year by 20%. Find the estimated value at the end of 4 years. Right. At the end of first year, the value of the machine, let's say the value of the machine is V at the start of first year. After first year is going to be 4V upon 5. Right. After the second year is going to be 4V upon 5 into 4 upon 5, and that is going to be 16 upon 25V. So if you see this, the value of the machine after nth year is going to be value from the start into 4 upon 5 raised to power n, right? So when you do this, you would have 15,625 into 4 upon 5, because it depreciates 20% every year. I have multiplied by 4 upon 5 because 80% of the value is remaining. So after the first year, it's going to stay 4 upon 5, right? So it would be 4 upon 5 is to 5. So it would be 15625 into 4 raised to power 5 is nothing but 1024, and 5 raised to power 5 is nothing but 15625. This and this is cancelled. The value of the machine after 5 years is just going to be rupees 1024, right? Moving on to question number 18. This is going to be the last question for this exercise and for this chapter as well. 150 workers were engaged to finish a job in a certain number of days. 4 workers dropped out on second day. 4 more workers dropped out on third day, and so on. It took 8 more days to finish the work. Find the number of days in which the work was completed, right? So we have, let's say that 150 workers, each worker puts in 1 unit effort each day, right? So 150 workers would put in 150 unit effort each day, correct? Therefore, the amount of duration, the amount of effort that it took to complete the job is going to be 150 into D, where D is the time expected, right? However, we know that it took 8 more days to finish the job than it actually happened, right? So 150D is equals to 150 plus, so 4 workers then dropped off on the second day, so you now have 146, then you would have 142, and this went on for D plus 8 days, right? So I've done nothing, but I have extrapolated the effort. I've equated the effort on both sides. 150D is equal to 150 plus 146 plus 142 for, and the number of terms in this side of the equation are going to be D plus 8, because it takes D plus 8 more days to complete the work than it actually did, right? So in the LHS you have 150D equals, so now you have D plus 8 terms here. So D plus 8 by 2, because we are adding up an AP. 2 times the first term, 2 times 150 is equal to 300, plus n minus 1 is going to be D plus 7 into minus 4, correct? This is going to be, so in the this side you would have 300D, or let's say here you have 150D itself. Here you have D plus 8, and you can take 2 inside here, so you would have 150 plus minus 2 times D plus 7, right? So here you have 150 D equals to D plus 8. In the brackets you have 1, so you would have 136 minus 2D, and you can again take 2 common out from this bracket as well, and what you would now have is 75D equals to D plus 8. You have taken out 2 common from here, so now you would have 68 minus D, right? Multiplying these two terms, you would have 75D as being equal to minus D square plus 544 minus 8D plus 68, right? So you have 75D equals to minus D square plus 60D plus 540. So taking everything out on the LHS, you have D square plus 15D minus 540 equals to 0, right? Therefore, 544 can be written as 32 into 17. So you have D square plus 32D minus 17D minus 544 equals to 0. You can take D out common, you have D plus 32. Here you can take minus 17 out common, you have D plus 32 equals to 0. D is equals to 17, or D is equals to minus 32. Number of days required to finish the project cannot be negative, so we'll reject this value. Number of days that it took to complete the project is, so the D, or the number of expected days it would have taken to complete the project is 17. So D plus 8 is the amount of time it actually took, and that is going to be 25, right? That is the final answer. And yeah, this was the chapter sequence and series. We have completed each and every exercise, and we've seen every question. We have done everything. Now I would request you all to try these questions yourself, and if and when you feel as if you have grasped the concept thoroughly, you can move on to the exercises, move on to exercise from different practice books of your choice, right? So this is all from my side. Thank you.